Alright, welcome. This is 2.6, proving angles are congruent. So you're going to make sure that you have that at the top of your header. And our objective, yes, you guessed it, is to prove and apply theorems about angles. Okay. Alright, so here we go. We have right here, our first thing that we're going to write down is we're going to write the definition of a theorem right here. So a theorem is a conjecture or statement that you can prove true. So that's the most important part, is that you can prove a theorem true. So we talked about postulates. Remember, we had our segment postulate and our angle postulate. Postulates are facts that we accept to be true. Theorems, on the other hand, the difference is a theorem we can prove to be true. And how do we prove a theorem to be true? Through our proofs. So that's why we learn about our proofs, so we can get our theorems. Okay. So our first theorem right here, and we're going to write this box down and make sure you have the picture drawn, is our vertical angle theorem. So we talked about vertical angles. We said angle 1 and 3 are congruent, and angle 2 and 4 are congruent as well. Okay, so again, theorems can always be proven true through proofs. Okay, so let's take a little bit closer look at what that would look like. So if we were to try to prove this true, we could set up our proof right here, and this is what it would look like. We would have our proof with our statements and our reasons. No, you do not have to write this down. So just this would be how we are proving this theorem to be true. So we have our statements and our reasons, and through our properties and definitions that we can prove that vertical angles are congruent. Okay. All right. So let's go on to our next. Let's go here, right here. Theorem number 2, you're going to write this box down right here. Theorem number 2. So theorem number 2 talks about congruent supplements theorems. And congruent supplements theorems is if two angles are supplements of the same angle or congruent angles, then the two angles are congruent. So if angle 3 and 1 were supplementary, which means that they add up to 180 degrees, a straight line, and angle 3 and angle 1 were also supplementary, which means they add up to 180 degrees, then that means that angle 1 and angle 2 would have to be congruent. They'd have to be the same angle measure. Okay? And we could prove that to be true through our proofs, but we're not going to show you that. We're just going to go on to our next one right here. So our next one, theorem, we got a couple right here, and we're going to write each of these down. We got theorem 2.3. We're going to write all that down with the pictures. So theorem 2.3 says if two angles are complements of the same angle, then the two angles are congruent. So again, complements means that they are complementary, which means that they add up to 90 degrees. So if 2 and 1 added up to 90 degrees, and 2 and 3 add up to 90 degrees, then that means that 1 and 3 have to be congruent. Same thing with right angles. If angle 1 and angle 2 are both right angles, then that means they have to be the same. They both have to be 90 degrees. Okay, and then theorem 2.5 right here, let's write this one down. If two angles are congruent and supplementary, then each angle is a right angle. So these two, when we put them together, supplementary means that they add up to 180. So it means that each of them, if they are both right angles, which means they are both 90 degrees, means they both have to be the same angle. Okay? Perfect. Alright, so let's get to some examples. Alright, so example number 1 right here. Example number 1. Okay, so it says, what is the value of x? So because we have our theorem, which we can always prove, that vertical angles are congruent, meaning that they are the same, we can use that theorem in order to solve for this. So if 3x was the same as 2x plus 8, if these two angles were congruent right here, it means that we can now take 3x and set it equal to 2x plus 40. Alright? So with our theorem, we can now solve this problem. We can figure out what x is. So we are going to subtract. We're going to subtract 2x from both sides. And boom, we get 1x, or x equals 40. Got it, right there. Problem number 1 down. Next problem. Alright, last problem, problem number 2. So you're going to have 2 right here. And so we are going to prove using the vertical angles theorem. And we are given that angle 1 is congruent with angle 4. And we want to prove that angle 2 is congruent to angle 3. Alright, so we are going to set up our 2-column proof. So we're going to have statement right here, and then we're going to have our reasons right here. Okay, and then our first one, the easiest one that we should always get, is the given. Okay, so what did it give us? It told us first that angle 1 was congruent with angle number 4. And our reason, easy, it was given. Alright, so before we attack this problem, let's just kind of think what's going on right here. Okay, first, we want to prove that 2 and 3 are the same, that they're congruent. Okay, if we're looking at it, it tells me that 1 and 4 are congruent, and 1 and 4 are supplement, that they make 180 degrees. They are supplementary, linear pair. Then that means that both of these have to equal 90 degrees, right? In order to equal a linear pair, both have to equal 90 degrees. Well, if those are both 90 degrees, then angle 1 and 2 also make a linear pair, so that also needs to be 90 degrees, which means that this one right here also needs to be 90 degrees. So they're all 90 degrees, which means if they're all 90 degrees, then angle 2 and angle 3 would have to be the same because they're both 90. Okay, so now we just have to explain that. So that's our big problem. Big challenge. Okay, so first thing that we're going to do, we have angle 1 and angle 4 are congruent. We are, and let's clear this right here. Whoops. Let's erase this, yeah, right here. Alright, we know that angle 4 and 2, so angle 4 is congruent with angle number 2. 4 and 2 right there, how do we know that? They are vertical angles, and we know that through our vertical, and we just do a little angle, and we say theorem. Angle theorem right there. Okay, vertical angles are congruent. We use our theorem in order to prove that. Boom. Okay, so we got angle 1 and 4 are the same, and now we just said 4 and 2 are the same. So you see right here how these right here are congruent. Well, because these two are congruent, we can now say these are congruent through our transitive properties. So we got to know all our properties. Okay, so these both share a 4, angle 4, and because they both have an angle 4, then this angle 1 and 2 are now congruent. So I would say angle 1 is congruent with angle number 2. And what is my reasoning behind that? Is my transitive property. Alright, so I got angle 1 and I got angle 2. Okay, next. Well, what else do I know about this picture? Well, 1 and 3 are also vertical angles, and those would also be congruent to each other. So I could say angle 1 is congruent with angle 3. And we would know that through our vertical, and we'll just abbreviate, angle theorem. Okay? Vertical angle theorem, we just wrote down that they are congruent to each other. Okay? So now angle 1 and angle 3 are congruent. Well, do we see right here how both of these have a 1 right here, right? Angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. So what does that have to mean? That because they both are congruent to angle 1, that these two also have to be congruent. That's my, again, my transitive theory. Property, not theory. Property. I would say angle 2 is congruent to angle 3 through my transitive property. So what's my reasoning right here? My transitive property. Boom. And then remember, whenever we're doing this, my last line right here in my statement should match what I'm trying to prove. Did we just prove that? Yeah, we did. We just proved that angle 2 is congruent to angle 3. So when it comes to proofs, you're going to really need to know all the properties. You're going to need to know these theorems now. You're going to need to know our postulates and then the definitions, right? Because we can use the definitions like the definition of linear pair, supplementary angles, complementary angles. You need to know all that stuff in order to do these proofs. So if you don't know it, make sure that you're looking it over and you're kind of memorizing it, because when it comes to the test, in order to do these proofs, all these right here, you have to know all those properties, definitions, postulates, and now theorems. Okay? Perfect. Sounds good. See you soon.